Learn like a pro.
You know, you've probably seen magnets stick to your fridge a million times, but have you ever really stopped to think about what's happening? Like way down at the atomic level? It can feel a little bit like magic, but it's actually a fundamental force of nature. And it all comes down to one surprisingly simple, really powerful idea. So let's peel back the layers and see what's really going on. See, the entire secret to magnetism, the whole shebang, is about turning chaos into order. We're about to see how getting the tiniest little particles inside a material to line up can unleash one of the most powerful invisible forces in the entire universe. Okay, so imagine a regular old piece of iron. Inside it, there are millions of these tiny magnetic regions we call domains. Now, as you can see here, in an unmagnetized piece of iron, these domains are a total mess. They're in a state of complete chaos, kind of like a huge crowd of people all pointing in random directions. Because they're all over the place, they just cancel each other out. And that's why a plain old nail doesn't stick to your fridge. But watch what happens when we bring an external magnetic field nearby. All of a sudden, all of those chaotic domains just snap into perfect alignment. They stop fighting each other and start working together, projecting one single, powerful magnetic field. And just like that, a simple piece of metal becomes a magnet. Pretty incredible, right? So what exactly is a domain anyway? Well, you can think of it as the basic building block of magnetism. It's a tiny little region where all the electrons in a group of atoms are spinning in the same direction. This creates a sort of mini magnetic field. The real power, though, is unleashed when you get billions and billions of these domains to all point the same way. All right, now that we kind of get what's happening at the atomic level, let's zoom way out and see how this force plays out on a much, much larger scale. Because this newly created magnetic field doesn't exist in a vacuum, right? It has to interact with the biggest magnet we know of, our own planet Earth. And this slide right here shows a universal rule of magnetism. If you let any magnet move freely, say, hang it from a string, it will always align itself with the Earth's magnetic field. One end will always point toward the geographic North Pole, we call that the north-seeking pole, and the other end will point south. So in a way, every single magnet is basically a natural compass. But that brings up a really interesting question. Why does some magnets, like the ones on your fridge, stay magnetic for years and years, while something like an iron nail only acts like a magnet for a moment? Well, it all comes down to what we call the material's magnetic signature. It turns out different materials have different abilities to remember this magnetic order. Take soft iron. It's super easy to magnetize, but it forgets just as quickly. That makes it perfect for temporary things, like electromagnets. Steel, on the other hand, it's stubborn. It's much harder to get its domains to line up, but once you do, they stay put. And that's how you create a permanent magnet. So one of the most powerful ways to force this alignment is by using electricity. You can wrap a material in a coil, which is called a solenoid, and then run an electric current through it. This creates a really intense magnetic field that basically forces all those internal domains to line up. If you use steel, you've just made yourself a permanent magnet. And if you use soft iron, you've got a powerful electromagnet that you can turn on and off with just the flip of a switch. Now, just as you can create order with energy, you can also destroy it. If you violently shake up those perfectly ordered domains, you can scramble them right back into chaos. Hitting a magnet with a hammer, for example, introduces a physical shock. And heating it up floods the material with thermal energy. Both of these methods just agitate the atoms and disrupt their alignment, effectively erasing the magnetism. Okay, so time for a little thought experiment. We've seen how magnets work, but how can you be absolutely 100% sure that what you're holding is a true magnet and not just some piece of metal that's being temporarily influenced? Well, there's only one surefire way to tell. Let's set up the problem. You have a magnet you know is real, and you see it attract an unknown metal bar. So that proves the bar is also a magnet, right? I mean, it seems obvious. But here's the thing. Attraction can be really, really misleading. And here's exactly why attraction can be so tricky. As you can see up top, unlike poles will always attract each other. But here's the catch. A magnet can also induce temporary magnetism in a regular piece of iron and then attract it. Repulsion, on the other hand, what you see on the bottom row, that's a whole different story. It only happens when two like poles, two norths or two souths, are pushed together. So here's the bottom line, the big takeaway. Attraction proves almost nothing.
Because any magnet can temporarily align the domains in a nearby piece of metal and then pull it closer. It's only repulsion, that unmistakable invisible push between two magnets, that is the definitive absolute test that both objects had their own permanent self-sustaining magnetic field.
So, after all that, we can really boil everything we've just uncovered down to 4 simple laws that govern this entire invisible world of magnetism.
First up, alignment is everything. That's the core idea, right? Magnetism is born when atomic chaos snaps into perfect order. Second, repulsion proves permanence. Remember, it's the only test that isn't misleading. Third is energy dictates state. An electric current can create order, while things like heat and shock can destroy it. And finally, number 4, materials decide function. Soft iron is for temporary stuff, while hard steel is for creating a lasting force. So what's the big idea to walk away with? Magnetism isn't really a thing you can hold in your hand. It's a state of being, a state of perfect atomic order. The power was always there, just hidden inside the material, waiting in chaos. So the real question is, now that you know how to bring order to that chaos, what forces will you choose to control?